Let's take a look at the components found in a typical disc brake system. We have the wheel hub assembly, the brake disc, the brake caliper assembly, the wheel, and the wheel nuts. The wheel hub assembly attaches to the chassis of the vehicle and holds the brake disc and wheel. A bearing inside the wheel hub assembly allows the wheel and brake disc to rotate smoothly. This vented brake disc consists of two round metal plates, inside which there is a metal venting system. Brake pads squeeze against the disc to create friction, slowing the wheel. Friction creates high levels of heat, but the venting system reduces this heat by helping to circulate air, cooling the disc. The brake caliper assembly provides the mechanism for squeezing the brakes against the brake disc. It typically comprises of a caliper body, carrier, and brake pads. First, let's look at the caliper body. When the brake pedal is pressed, pressurized hydraulic fluid pushes out the piston. When the brake pedal is released, the piston reverts back to its original position. Externally, an outer seal and dust boot protects the piston from dust and contamination. Next we have the carrier, which is a cast metal frame mounted to the vehicle. It holds the brake pads and caliper body. Two slider pins allow the caliper body to slide back and forth as the piston moves. Brake pads squeeze against the brake disc and produce the friction required to slow the vehicle. At the back of the brake pad there is a shim, which is designed to reduce vibration and noise. Next, we have the steel backplate, which provides the rigid base for the friction material and solid mounting to the caliper piston and carrier. An underlayer, sandwiched between the backplate and friction material, bonds the two together and acts as a thermal barrier to stop heat being transferred from the pad to the caliper. Finally, we have the friction material, which is made from a variety of compounds designed to offer a combination of stopping power, longevity, strength, and comfort. The brake pads are often held in place by springs, pins, or in our case, a clip. These accessories should always be replaced when brake pads are changed. Now, let's see how these components all work together. The brake pedal is pressed and pressurized hydraulic fluid enters the caliper body. Hydraulic pressure pushes the piston out, first forcing the inner brake pad against the inside of the brake disc. As this happens, the inner piston seal deforms. Now, the inner brake pad cannot travel any further, so hydraulic pressure forces the caliper body back along the slider pins, pulling the outer brake pad against the outside of the brake disc. When the brake pedal is released, the inner piston seal reverts to its original position, withdrawing the piston. Let's take another look at this again from above. Pressurized hydraulic fluid enters the caliper body. The piston pushes the inner brake pad against the brake disc. When the inner brake pad reaches the extent of its travel, the outer brake pad is then pulled against the brake disc, slowing the wheel. And that's the basics of a typical disc brake system.